Welcome to solverfy.
Hello, my name is Margaret, and today I'm going to be helping you with a problem from Chemistry, the Molecular Nature of Matter and Change 2016. And we're going to work on problem 36 from chapter 8. And it's given us the partial orbital diagrams, and we're asked to write the condensed electron configurations and group numbers. A is a little tricky, so we're going to actually start out with B and then come back to it. So B, let's start out by writing the end part here of the electron configuration. So 2s2, 2p3. Right, so if we come here to the p block, 2p3 would be 1, 2, 3, so that's nitrogen. Right, so group 5 or 15. Ooh, the computer made a noise, sorry. And then the most recent noble gas from that would be helium. Awesome, great. So that's that problem. So if we come back to A, we are missing some electrons. None of the elements quite do what's going on here, right? Because if we start by writing this out, we are saying 5s1, 4d4. And this isn't a stable configuration. Nobody's really going to do that. However, and this is obviously, and because as it is right now, this is an ion. So what we are going to do is we're going to start by adding an electron back in one at a time and start to see if it matches an electron configuration that we know. Okay, and so to do that, we're going to use it. I'm going to use a different color than I normally would, and in order to help us keep track. So I'm going to use green since that's not a color I normally use. And so we're going to add it in the place that I know that it would most naturally go first. So because this is obviously a transition metal complex, you know, your question is really, well, okay, well, would it go here or would it go here? And you're torn between, well, wouldn't it go here because this is the lowest state? Well, you know, remember your weird cases of chromium and copper, right? Because they're right before the places of manganese and zinc, the ones that are 5 and 10, they have that tendency to take this paired electron and shift it over here, right? So I could put it back in right here where the lowest place is and pair it off, but it's actually going to immediately shift that electron over here in order to fill the d orbital, because the filled d orbital is lower in energy than the unfilled 5s and the paired 5s. So it's going to do this instead, right? So if we write out this electron configuration, we have 5s1, 4d10. And we know that to be, and even if we had put this electron here and written 5s2, 4, oh, I'm sorry, that's not 10. 4d4, or sorry, this is going to be 45. 45, and this is 44. Either way, we know that this is going to end up being, so if we come down to the fifth row, so 1, 2, 3, 4, 5, and we're right here at rubidium, and so we count over through the 5s, which brings us through strontium. We count over 4. 1, 2, 3, 4. And that brings us to molybdenum. And because we know actually what element it is, I'm going to come back to the black. Sorry, I had to remember how to spell that for a second. Whose symbol, MO, that's a different problem. So our group number is 6. And sorry, this is an E right there. That, can't read that at all. Let me fix this. There you go. Group 6. So our actual electron configuration, remember, it's right before, because it's a group 6, which means that it's in position 4 of the transition metals. It's going to do this business right here. So if we go back to the most recent noble gas, that's krypton. So Kr in brackets, and then we write 5s1 4d5. And this is going to be our electron configuration. And so I hope I explained this pretty well for you, and I hope I gave you some ways to solve some trickier problems. I guess if you really wanted to get technical for this particular electron configuration, it would be Kr 5s1 4d4 for this specific electron configuration, and it's for molybdenum +1, hypothetically.